So welcome, this is EAI May-June 2008 M1 paper. So let us try to solve that paper, all the questions. It says a particle slides down a smooth plane. The smooth plane inclined at an angle alpha to the horizontal. So let me draw the diagram. There is alpha, then particle passes through point A and B. Point A and B, at A, its velocity is 1.5 meters per second. At B, its velocity is 4.5 meters per second, and the distance we don't know, and the time taken is 1.2. Find the acceleration of the particle. So u is equal to, so what is u is equal to 1.5 meters per second, v is equal to 4.5 meters per second, time is equal to 1.2 seconds, acceleration is equal to question mark. So v is equal to u plus at. So 4.5 is equal to 1.5 plus a times 1.2. From there I get the value of a as 2.5 meter per second square. Now we know one formula: forward force minus backward force is equal to ma. So what am I going to do? I'm going to resolve the forces over here. This is mg, so this becomes mg cos theta, mg sin theta, and r. So those are the forces. So forward force is mg sin theta or sin alpha, minus backward force is 0 because there is no friction, is equal to ma. So m and m gets cancelled, so acceleration is equal to g sin alpha. So 2.5 is equal to g 10 sin alpha. From there sin alpha is equal to 2.5 by 10. Alpha is equal to sine inverse 2.5 by 10, which I get 14.5 degrees. That's going to be the answer. Now coming to the second question. A block is being pulled on a horizontal fold by a rope inclined at 20 degrees to the horizontal. So there is a horizontal, there is a block which is being pulled 20 degrees to the horizontal. So this angle is 20 degrees and the force is 851 newtons at a constant speed 2.5. So what am I going to do? I'm going to resolve the forces. So this becomes 851 cos 20, and the upward force will become 851 sin 20 r, and its weight will be mg. That is the way how do I resolve the forces. Now show that the work done. He's asking work done. Work done is equal to force times distance, that is force times distance. The distance over here will be speed in times time, speed times time. So the force will be 851 cos 20, the speed is 2.5 and time is 12 seconds. So when I do that I get 24,000 joules or 24 kilojoules. Hence find the power. So formula for power is equal to work by time, work divided by time. So work I get 24,000 divided by time is 12, so 2000 watt or 2 kilowatt. Coming to the third question. As soon as you see this question, first resolve the forces without reading anything further. First resolve the forces. So F, I resolve one horizontal and one vertical. So this becomes F cos theta, F sin theta. 13 newtons and 10 newtons I need not resolve because they are already perpendicular or horizontal. He says that three horizontal forces act on a fixed body and they are in equilibrium. Equilibrium means left side force should be equal to the right side force. So left side force is F cos theta is equal to right side force is 10N, or right side force is F cos theta, left side force is 10 newtons, so F cos theta is equal to 10. And next one is upward force is equal to downward force, so F sin theta is equal to 13. So now divide both. F sine theta divided by F cos theta is equal to 13 upon 10. Tan theta is equal to 13 upon 10. Theta is equal to tan inverse 13 upon 10. So from there I get theta value as 52.4 degrees. Now I need to negate the value of F. So what am I going to do? Substitute this theta value there. So F sine 52.4 is equal to 13. From there I get F is equal to 16.4. Question number 3. OABC is a vertical cross section of a smooth surface. The straight line OA has a length 2.4 and makes an angle 50 degrees to the horizontal. A and C are on the same horizontal level. B is the lowest point. Particle of mass 0.8 kg is released from rest. Find the kinetic energy of P at A. It is been asked, find the kinetic energy of P at A. So what am I going to do? I am going to do TWD is equal to delta KE plus delta PE plus WDF. What is TWD? TWD means total work done. WDF means work done against friction. Work done against friction, because it is smooth, so work done against friction is 0. Total work done is 0 because we are not pulling it. So delta KE, what is the meaning of delta KE? Final kinetic energy minus initial kinetic energy. Then delta PE, what is the meaning of delta PE? Final potential energy minus initial potential energy. Okay, so and work done against friction, we have just seen that its value is 0. So this is a formula. So we want to know speed of P at A. So 0 is equal to final potential energy 1 by 2. Find the kinetic energy of P at A. So final potential kinetic energy is only been asked. So I want final kinetic energy minus initial kinetic energy is 0 because it is starting from rest, plus final potential energy is 0 minus initial potential energy is mgh. What is the mass of the particle? 0.8 and g is 10 and height h. What is height h? Let us calculate height h. Height h, this is a triangle. Sine 50 is equal to h upon 2.4, so h is equal to 2.4 sine 50. So h is 2.4 sine 50. From there I get final kinetic energy is equal to, simplify that, 14.7 joules. Now speed of P at C. So whatever is the speed of P at A will be the same as speed as P at C because they are at the same level. So kinetic energy at C also will be equal to 14.7 joules. So half times m and v square is equal to 14.7. So from there I get v value is 6.06 meters per second. That is the speed of v at C. The greatest speed of P is 8 meters per second. So let me clear off all these diagrams. Now the greatest speed is 8. Over here the speed is 6.06. Over here the speed is 6.06 meters per second. And at B it is 8 meters per second. What is being asked? What is the depth below? So depth below, this height below capital H, it is being asked. So what am I going to do? I am going to take the same thing, total work done is equal to delta KE plus delta PE plus work done against friction. I am going to take the same thing, total work done is 0. Now final kinetic energy I take only from A to B. So 0 is equal to final kinetic energy at B is 1 by 2 m 0.8, v square is 8 square, initial kinetic energy is 0.8 times 6.06 whole square. This is at A. Same is the case. Final potential energy is mgh. M is 0.8, G is this much, and height is h. Initial potential energy we'll consider as 0. Let it be at A, we consider it is a starting level, so let it be 0. And work done against friction is again 0 itself. So from there, I get 0.8 times 10 times h is equal to 1 upon 2 times 0.8 times 6.06 whole square minus 1 upon 2 times 0.8 times 8 square. So I can cancel it out 0.8, 0.8, 0.8. So h is equal to 6.06 whole square by 2 minus 8 squared by 2 divided by 10. So I quickly take the calculator. 0.6 square minus 0.5 times 64 divided by 10. So when I do, I get negative 1.36, but it is the depth, because we are getting negative answer because it is below the ground. So the depth is equal to positive 1.36 meters. So depth is h is equal to 1.36 meters. Question number 5. A block of B of mass 0.6 kg. So this is 0.6. A of mass 0.4. So this value is 0.4 G. Block is held at a rest on a rough horizontal table, so there will be a friction. So mu r, because obviously it will move towards the right, so friction will be towards the left, r. The coefficient of friction is 0.5. The spring passes this much. The particle of the string between B and C is horizontal. Distance is 3 meters. Released to move. Find the acceleration. So if we remember, we take the formula. What was that formula in the one of the question we have used? This formula we use. Forward force minus backward force is equal to ma. I go back and use that formula. Forward force minus backward force is equal to ma. So for A, so the tension will be always acting towards the pulley. A is coming downwards, so therefore forward force is 0.4 G minus tension is equal to 0.4 A. For B, tension is a forward force, backward force is mu R, mu is 0.5, R is 0.6 G is equal to 0.6 A. Add them, tension gets cancelled, 0.4 minus 0.5 times 0.6 G is equal to 1 A. From there, I get the value of A as 1 meter per second square. Substitute this value of A in one of the equations. 0.4 G minus tension is equal to 0.4 times 1. From there, I get the value of tension as 3.6 newtons. Find the time taken by B to reach the pulley. So for B, initial velocity is 0. Time is being asked. Distance is equal to 3 meters. It has to travel 3 meters to reach the pulley. Then acceleration is 1 meter per second square. So I use S is equal to ut plus half at square. So 3 is equal to 0 times t times plus half times 1 times t square. So t square is equal to 6. So t is equal to square root of 6. So t is equal to 2.45 seconds. Question number 6. A particle P of mass is projected vertically upwards with a speed of 5.2 meters per second from a point which is 6.2 meters above the ground. So, diagram 6.2 meters. From here, I am throwing a particle upwards with 5.2 meters per second. So, means obviously it goes up and comes down and falls down. Comes down and fall. Air resistance while going up is, so acceleration while going up is minus 10.4 meter per second square, and acceleration is 9.6 when it is moving down, so plus 9.6 when it is moving down. Find the greatest height. So greatest height, let us consider greatest height. This is the part, the green color part is the greatest height, h. So for that part, initial velocity is 5.2, final velocity is 0 because at greatest height it has to stop. Acceleration is minus 10.4 meter per second square. So S is equal to H. So we use V square is equal to U square plus 2AS. So 0 square is equal to 5.2 square plus 2 times 10 minus 10.4 times H. So from there I get H value as 1.3 meters. But he's asking total height above the ground. Total height above the ground, above ground level, will be 1.3 plus 6.2, which is 7.5 meters. The speed with which P reaches the ground, the next part. So it starts from here with velocity 0. It falls all the way of height 7.5 meters. What is the velocity with which it reaches? For that, acceleration is 9.6. So U is equal to 0, V is equal to question mark, acceleration is equal to 9.6, distance is equal to 7.5 meters. So again I use V square is equal to U square plus 2AS. So V square is equal to 0 square plus 2 times A is 9.6 times 7.5. From there I get V value as 12 meters per second. Last part, total work done by P on P by the air resistance. Total work done. If we remember, we have a formula for total work done. This is a formula for total work done. We take that formula and we take this formula better. Total work done. Where is this? Okay, we paste it here. Total work done. So here total work done is being asked. So TWD, we don't know, it's not 0. Total work done against total work done by the and work done against friction. Now total work done is 0 because we are not pulling it. So final kinetic energy. So let us do in different colors. Final kinetic energy 1 upon 2 mass. What is the mass of the body? 0.6 kgs. 0.6. Final kinetic energy is the energy at the ground, right? Its velocity was 12 square minus initial kinetic energy. It was thrown with 5.2, so 5.2 square. Final potential energy is 0 because at ground it was 0. Initial potential energy is M is 0.6 times G is 10 times H is 6.2 plus work done against friction. So work done against friction we have to find. So WDF is equal to 0.6 times 10 times 6.2 plus 1 upon 2 times 0.6 times 5.2 square minus 1 upon 2 times 0.6 times 12 square. Simplify that. You should be able to get that answer as 2.11 joules. That's the answer. So simple formula, use that formula. So to final kinetic energy is the kinetic energy when it's on the ground, and initial kinetic energy is at the top of the, what was that, top of the point, top of a pole, maybe we can say top of the pole, and final potential energy is at the ground, which is 0, and it is at the top of pole is initial potential energy, and work done against friction has to be found out. Finally, question number 7. An object P travels from A to B in 80 seconds. So total time is 80 seconds. The graph consists of a straight line segments for 0 to 10. So 0 to 10 is a straight line. So this is a straight line. And 30 to 80. 30 to 80 is also a straight line. So remaining part is a curve. The curved part. Find the maximum velocity of P. So the maximum velocity of P occurs only during the curved part. So V is equal to minus 0.01 t square plus 0.5 t minus 1. So find dV upon dt. Minus 0.02 t plus 0.5. So it should be equal to 0 at maximum point. First derivative is equal to 0. From there I get the value of P as 0.5 divided by 0.02, so which is 25 meters per second. Is it 25? No, 25. So for 0.5, this is a time, 0.5 divided by 0.02, which gives me 25 seconds, the time, but is being asked, the velocity is asked. So therefore I go back and plug in this one, 0.01 times 25 square, then plus 0.5 times 25 minus 1. So let me take the calculator, and 25 square minus 0.5 times 25 minus 1. So 0. I do that. So how much do I get? I get the answer as 0.25 square plus, let me check, t square minus 0. So it is minus. So when I do that, minus 0.01 times 25 square plus 0.5 times this one. When I do that, am I going to get it as 5.25 meters per second. That's going to be the answer. The distance AB. He is asking us to find it out, the distance AB. So I have to find it out, the distance AB. So what am I going to do? The curve is starting from, we can see that, let me draw it out in this part. The curve is starting from 10 to 30. So I find velocity at 10. So minus 0.01 times 10 square plus 0.5 times 10 minus 1. So what does that happens? How much is that? So let me pull up the calculator and plug in. I'm taking the calculator and getting the value as 10, so it becomes 3 meters per second. So velocity at 10 is 3, so this height is 3. Similarly, I find velocity at 30 seconds. So velocity at 30 seconds, so substitute 30, go back and change the values in the calculator as 30. So when I quickly do that, I get the answer as 5 meters per second. So in the diagram, this height is 5 meters per second. So there are 3 parts in the diagram. So he's asking the distance. So area. Distance is nothing but what? Area is the distance. So there are 3 parts. So triangle plus area under the curve plus triangle. So the first triangle, it is half times base is how many seconds it is there? 10 is the base, height is 3. For area of the curve will be from 10 to 30. I use the integration 0.01 t square plus 0.5 t minus 1 dt, and area of the triangle, third triangle, is half, base is 32, 80 is 50, and height is 5. 50 times 5. So this becomes 15 plus 0.0 minus 0.01 t cube by 3 plus 0.5 t squared by 2 minus t from limits 10 to 30 plus 250 by 2 is 125. So when I plug in, it becomes 140. Then substitute the upper limit, minus 0.01 t cube, 30 cube by 3 plus 0.5 by 2 t square, 30 square minus 30, minus substitute the lower limit, minus 0.01 10 cube by 3 plus 0.5 by 2 times 10 square minus 10. Simplify this total answer should be 233 meters. That is going to be the answer for the total question. Do you have any another part? No, that's all. So that completes all the 7 questions. See you in the next paper.